Thank you for joining me today. This is our first basic networking class, and we're going to be discussing IP addresses. The purpose of this class is to provide the foundations for understanding what IP addresses are, how you use them, and simple troubleshooting techniques you can use. This is not the equivalent of a full CompTIA certification class. For something more extensive, I would recommend using LinkedIn Learning through our library's website. Our goal today is simply to introduce the topic and explain the fundamentals. What we're going to be covering today is a brief history and overview of IP addresses. We'll talk about why you would learn this information. We'll take a closer look at the structure of IP addresses and learn about some of the properties related to IP addresses that are important to know. And we'll look at some troubleshooting tools and learn about the problems that you could find with them and what you would do to solve them. IP addresses were created with the intention of giving everything on the internet its own unique address so that it could be identified as something that was connecting separately from all the other devices that were making this up. Understand, of course, this was done in the early days of the internet when there were not many devices out there, and so they had no idea the number of things that were going to be required of it going down the road. This comes into play when we talk about why we have created a new version of IP addresses to accommodate more items. We'll get to that in just a few moments. Now, Internet accessible devices can have both public and private IP addresses. Public IP addresses are assigned by a governing body. You see I have them listed there, IANA and ICANN. The IANA assigns them and ICANN organizes them, and they must be unique. They are assigned by Internet service providers. Blocks of addresses are assigned to regional Internet service providers, and then smaller blocks are registered to the normal Internet service providers. These would be the people that you pay, like Comcast or AT&T, to connect to the Internet. And then the hosted servers can have individual registered addresses with them. Private IP addresses, on the other hand, are used within internal networks and can be duplicated in unrelated networks. So you don't need to worry when you are creating an internal network what somebody else is using for the address in theirs. On the other hand, those addresses cannot be used to access the internet without the use of a gateway which would have a public address with it. If all that seems a little confusing and convoluted, one way of looking at it is that whatever device you use to connect to the internet, and it's a cable modem or a Wi-Fi access point, however you get there, that has its own public IP address, and that has to be unique, and that is controlled by organizations that keep track of what all of the addresses are so that they know there will be no duplicates. Within your home or within your group of devices that are using that way of accessing the internet, you can do whatever you want with the private IP addresses within certain bounds. Those are assigned by you, and they can be whatever you want within your network. So why are we learning this? Why are we going through the trouble of talking about this? Some of it can be a little bit confusing. Well, there's two types of people who might be interested in this information. First, let's talk about home users. If you just want to learn more about how your computer works and you're interested in networking, you want to set up some connected devices at home, maybe you want your computer and your spouse's to be able to talk to each other and share resources, maybe you have a printer that you want to connect, whatever it may be, then you might be interested in learning some more about networking and how IP addresses function. For the home user, you're typically going to be okay with the automatically assigned private IP addresses. We'll talk more about that in just a few moments. You will also not have a lot of control over your public IP address. That is something that's going to be assigned by your internet service provider, and it usually will not be consistent. If you need to have the same public IP address every time you connect to the internet, you can do that. They tend to charge extra for that. So if you contact your internet service provider, you can get a fixed IP address. For most people, there's no point to that, and it's not something that I would recommend. There are a couple of exceptions to what I just talked about. For the private IP addresses, you might want to use a fixed one if you have a resource that you are trying to share and you want all the other devices to be able to find it all the time. Then you might need to give that a specific name and a specific fixed IP address. We'll talk more about how you would do that later on. For the public IP address, you might take a little bit of control over what your public IP address is by working with a VPN or virtual private network. Now, for most people, this isn't necessary, but if you're concerned about security or privacy, then you might find that you have success with adding on a virtual private network. There are some that are available for free. There are others that you pay for. This is something that you run on your computer, and it connects you through your internet service connection, through your internet service provider, to another location, and then it shows your public IP address as something else that was provided by a different company. This is done to mask your location or identity if you're concerned with tracking information or other things like that online. It can be helpful for reducing the amount of risk to private information that's sent around. The security is typically better than it would be over an internet service provider, and it does change what your public IP address is. But again, for most people, the public IP address is just going to be what was assigned to them by the ISP when they connect. Now, for professional users, you might have a different interest in learning more about private IP addresses. If you're trying to maintain or troubleshoot a organization's network, then you're going to run into situations where the private IP addresses might have some problems, and you're going to need to know how to assign or how to identify and change the IP addresses that you're working with. Troubleshooting potential network issues related to the IP addresses can save you time and confusion, as I list there, because very often you will have a computer that is not able to use a resource. It's not able to connect to a web-based file sharing system or a program that connects over the internet, and you might be wondering why, what's going on. Is the problem with the computer? Is the problem with the network? What's going on there? And some of these basic troubleshooting techniques that I'm going to show later on can help you identify what the problem is. Even if you're unable to fix it, at least you know where the problem begins. So when talking about the structure of the IP address, I broke this down into different categories of information that we're going to see when we're working with these things. I'm going to start out talking about IPv4. This is really the most critical one of all these that we're going to discuss, because this is the one that you'd most likely be interested in or have to make changes to or work with. While IPv6 are increasingly common, and you're going to see them very frequently with things like cell phones, if you're working on a network either in your home or at an office, most likely the resources are organized via IPv4. Now, as we said before, IPv4 are 32-bit numbers divided into 4 8-bit sections separated by 3 periods. I have an example here where I show you the number 123.234.56.7. There's nothing magical about that example, it's just some random numbers that I tossed out. However, I did keep everything within the limiting spaces that you can have, or numbers that you can have. See, each of these 4 parts, each of these 4 sections of numbers has to be between 0 and 255 for an IPv4 number. That gives us, when you multiply them all the possibilities times each other, that gives us the roughly 4 billion possible devices that we can have for IPv4. Now, it's a little bit less than that because there are some restrictions, and by restrictions we mean reserved numbers that are not available for IP addresses. I've got some examples of them down here. There are a lot of different choices. Some of them are reserved for testing or for government use, but these are some general ones that you might run into in your normal everyday use of internet devices. And you can see the 10.0.0.0 through 10.255.255.255, and that's listed as a Class A private block. We're going to talk about all of those in just a few moments. The 172.16.0.0 through 173.31.255.255, that's a Class B private block. The 192.168.0.0 through 192.168.255.255, and that's a Class C private block. Now, what are the difference between these? Class A has a small amount of hosts with a large amount of networks that are available. I'll explain what that means in just a moment, but I want to give you comparisons first. Class B is somewhere in the middle. It offers more networks, but a significant number of hosts. So there's still a lot of options available with that. And Class C has smaller number of networks available, but a large group of host IPs within the same network. So, what are we talking about with networks and hosts? Well, we're going to talk about the subnet mask in just a few minutes. It's a little bit beyond the scope of this class, but a network administrator can use the subnet mask to control the number of possible separate networks that you have within your workplace or organization. And within each of those networks, you would have a certain number of hosts. And so if they are set up to have a large number of hosts, usually you have a smaller number of possible networks. If this is a little confusing, you don't need to worry about it too much at this point. What I just want to explain is that the ranges that are provided here start going from left to right. So the left are the bigger numbers that would be more important to not change. So you see here for this first one, where it's 10.0.0.0 through 10.255.255.255. Any numbers in between those two would start with a 10, but you would have a range of options for those 3 numbers that go afterwards. Whereas if we go down to the bottom where it's 192.168.0.0 through 192.168.255.255, you would have to keep the first two numbers the same. They would have to be 192.168, and you would have a range of possibilities with the second two. Now, these second two are going to be fixed or changing depending on the network setup. For most people viewing this, if you have a network at home that has a cable modem that you use as your gateway to the internet and that has Wi-Fi options available, if you were to look at the settings for it, the gateway would be listed probably as something like 192.168.10.1 or maybe .1.1, somewhere in that range. And then any devices that connect to it would be the same first three numbers as the gateway, and then the last number would be different. That is how these things typically provide a range that's available. So you're going to see that when you're looking at your DHCP assigned addresses that go through this, or if you create a fixed address where you're typing it in yourself, you'd want to make sure that it was in that range, starting out with the same prefix as the gateway, and then a different number at the end. Now let's take a look at IPv6. So these were created, as I said before, to accommodate more devices. We went from a 32-bit number to a 128-bit number. So this is significantly more possibilities. And we went from 4 8-bit numbers. So if we look back here, we had the 4 different sections separated by periods with 8-bit numbers in them, to 8 separated by colons, 16-bit numbers that use hexadecimal notation. If you've never used hexadecimal before, instead of going from 0 to 255, each individual number can be anywhere from 0 to the number 9, or it can use the letters A through F for 10 through 15 respectively. So that means that each of these numbers is 16 times 16 times 16 times 16 possibilities. So there are many, many, many possibilities for addresses using the IPv6. IPv6 does not require a subnet mask. It carries more information within the address itself. We're going to talk more about the subnet mask in just a moment. And the address contains extra information such as the transition types. There are 3 of those. Unicast, which is one-to-one, multicast, which is one-to-many, and anycast, which is one-to-many, but it finds the other routers on the system and it passes things through there. This is something that you'd worry more about with server administration. It's not something you'd be likely to change or deal with too much. And then the address types, which indicate there are 5 of those, whether they're global unicast addresses. Those are the equivalent to the registered public IP4 addresses, whether they're link local addresses, which are self-generating IP addresses automatically created by the client. Unique local unicast addresses, those work like those class A, B, and C that we had just talked about in IPv4. Multicast addresses, those start with 4 ones or 2 Fs, and those indicate that it is a one-to-many, or anycast addresses that work to identify routers within there. If you found all that a little bit confusing, that's okay. As I said, for the most part, you're not going to be working with IPv6 within a local network that you set up. These are the kind of addresses that you would see assigned if you check what your public IP address is for some newer devices, particularly things like cell phones. You will see an IPv6 address. So if we look at whatismyip.com, as I'm going to show you a little bit later on, when you're using your phone, you will see an address that looks a lot like the example that I gave here. Now finally, how do these get assigned? We talked before about how the IPv4 addresses are assigned either automatically using DHCP, we're going to talk about that in just a moment, or manually typing them in. The same is true with IPv6. They can use the dynamic DHCP or the manual allocation, but they also have a feature called self-allocation that is possible with certain setups. Again, this is something that you're not going to run into too much on local network administration, and something that's a little bit more of a server administration concern. So the subnet mask. We've talked about this in passing a little bit. This is again something that you would control if you were doing network design from a server standpoint and you wanted to control how many devices were possible on your network or how many what we call subnets are available. You create subnets when you want to have virtual networks that are separate from things within the same group of connected computers. So if you wanted to keep some resources separate, for example, maybe at your workplace you have networked computers, but you also have a wireless network, but you don't want them to share resources, you would create a subnet to be able to do that. The subnet mask is what you use to do that. It identifies the IP address into different parts, one part identifying the host computer, the other identifying the network to which it belongs, and using different subnet masks, you can create different possibilities there. Now, that being said, what I show here, the 255.255.255.0, is the most common subnet mask, and that is used for a very basic network that just has everything on the same network together within your local gateway. So that's what you're going to see more often than not. Again, the value for that can be adjusted by the network administrator. It's important if the network is different on the, if the subnet mask value is different on the network that's set on the gateway, for it to be consistent on all of the devices. So if you were to look at the gateway that you connect to and see that the subnet mask is something other than 255.255.255.0 on that, you would make sure that it is consistent across all the devices that you connect to that. Now let's talk about the DHCP. And while we're here, we're going to look at some examples of the network settings and things that we could change within the control panel. So the DHCP automatically assigns IP addresses to computers on the network if it is turned on to do so. The DHCP is what we're going to use most of the time. I mentioned this earlier. This is going to be simpler for most users. It's going to work out both in the workplace and at home for most situations. The network administrator would control some of the details of the DHCP server, such as the range of networks that are provided and the times that are provided for the leases, as we're about to discuss. Every time a computer connects, it leases an IP address, essentially borrows, from the DHCP server to use for however long the lease time is set in the server settings. The addresses can't be duplicated, so you can't have two devices on the same network with the same address, and they have to be renewed after the lease time expires. What does that mean practically speaking? Most of the time, if your computer remains connected, it will stay connected. But if you turn it off, or you connect again, or you turn off the internet access for whatever reason, maybe it's a wireless device and you leave and then you bring it back, it will ask for an address again, and very often it will get a different one from what it had before. Now, let's take a look at where we would see all of these settings we were just discussing. The IP, usually version 4, the subnet mask, and the DHCP. If you go to your control panel and your network and sharing center, you will see, as I'm showing down here in the bottom left, access type, internet, and the Ethernet connection. If you click on the Ethernet connection, or in some situations it might say Wi-Fi connection, when you click on that, that will take you to your network settings. I'm showing here the Ethernet status, and you can see underneath the connection information, it says IPv4 connection internet. IPv6 connectivity, no network access. That indicates that IPv4 is what we are using on this device. If the device were using IPv6, you would see the reverse. You see the media state enabled. This is important. If this was not enabled, if it was disabled, you would look down here to the bottom and you would not see a disable button, you would see a button that says enable, and you would click that to enable it. The duration is indicating how long your internet connection has been up and active for. And the speed is indicating the maximum speed that you can get with the equipment that you have. You will very rarely get that actual speed for anything traveling over the internet, but for local network connections, you might see some very fast connections going through, depending on how the physical network is set up. Some information about the activity that we see down here. You want to see these numbers going upwards as you're looking at them. Just in real time, if you sit and look at this setting, you should see both your sent and received numbers increasing. It doesn't matter exactly what they are. You will not match these exact numbers. These are just random things grabbed at the time that I looked at this screen. But you should see them going up. That means that your network is busy and that you are having traffic. And that's what you want to see. If there's a problem, or if you're just interested in more information, you can go into the Properties button that you see there. You also see the Disable button if you want to turn that off for whatever reason. And finally, you have Diagnose. If you are having a problem, you could try Diagnose. Sometimes that will find the problem for you. It's a built-in Windows tool. It's rarely successful, to be perfectly honest with you, but it's better than nothing, so you can give that a shot. Now, if you were to click Properties, that would take you up to the screen that I'm showing you in the upper right-hand corner here. This is showing all of the features of the network that are currently active. Anything that's active would have the check next to it. That is generally what you want to see. You want to have just about everything checked here. If for whatever reason you are having trouble and you wanted to remove possible problems, you could uncheck the IPv6 option that's available there, because you're probably not using it, and that could just be adding confusion. But if everything is working, there is no reason to bother with unchecking that. If you're looking for more information about your currently active internet connection, you could highlight the IPv4 and go to Properties on that, and that would take you down to the screen that I am showing you here. Now, for most users, you would have the Obtain IP address and Obtain DNS server selected automatically. We're going to talk about the DNS server in just a moment, so we're going to get to that shortly. But you would have those selected automatically, and you would not have to worry about these settings. I'm going to show you what that looks like in just a couple of slides. However, if you have a reason to manually set this, again, why would you do this? We talked about this a little bit earlier in class. You might manually set your IP address if, for example, this is a server. You don't want to have your servers changing their IP address over and over again. You want those to be fixed because the resources on your network are connecting to the server and drawing things from it, so you need to have a fixed address there so they can always go to the same place. You also, depending on setup, might want to have your printers have a fixed IP address. This depends on how the printers are installed on the computers. It's entirely up to you and whoever is administrating the network. But if you want to have those have a fixed address, you might have those fixed there as well. Sometimes you might even have the computers set to a fixed address if you had them set into groups. That is something that you can do. I would not recommend it, but some people do that within their network. So if you wanted to do that, you would click the radio button for use the following IP address, and you would need to fill in all of these attributes. Now, the IP address for the computer is something that you could choose as long as it was within the range that is set by the subnet mask and the gateway. The gateway gives you the starting parameters of this. You can see in this example, I have the 192.168.1.1. That would be my gateway. That's the IP address inside my private network for the device. If you're wondering, I don't know what my gateway is, how would I connect to that? You would simply need to connect to your internet access points, whether there's a wireless access point or a cable modem or other means of connecting to the internet. You would probably need to have a username and password to connect to that. You might need to plug a laptop or computer directly into it, or you might have an IP address that you were given by the internet service provider that you can go to and look at through a web console to manage the settings. But that would provide you all of this information. It would tell you what the subnet mask should be and what the gateway should be. You can, when you get more comfortable with this and feel more advanced, you can change those within your network. Just be careful because that can make it suddenly difficult to access the internet, so make sure you know how to physically connect to this by plugging a computer into your access point if you need to, if you lose internet connectivity and the ability to edit it through a web browser. Now, once you have assigned that information, you could assign a DNS server here. We're going to talk about how you would assign these in just a moment. This example that I'm using is the Google free DNS options that are available. You can see the validate settings upon exit. You would check that and click OK. What validate settings does is it tests to make sure that your internet connection is still active. If there is a problem, it would notify you of that through the validation process. After you say OK, it will go back to the Ethernet status screen, and when you click close, it may very well ask you to restart. That's perfectly okay. That comes up a lot when you do major changes to your settings. If it doesn't, that's okay too. Depends on the changes that you made, how things were working beforehand. Now let's briefly talk about the DNS. That is your domain name service. The purpose of the DNS is it takes a natural language, or just basic English computer name, and it maps that to the IP address. You might not think that you have a lot of experience with this, but if you've browsed the web, you have used a DNS before, because every website has a connection with a domain name service. So if you go to Ford.com or mybpl.org or whatever website you go to, that is taking that name and it is mapping it to an IP address that is associated with that website. Now, within a network, within a, say, private network, you have computers that are remotely connectable by name, if you know how to do that, and that is working using the DNS, the domain name service. That is also sometimes makes it easier to share or identify resources such as printers or scanners or other things that you have available to you on your network. If you don't want to set up your own domain name service, typically they're installed on either domain server or the gateway device that you're using to connect to the internet. But if you don't want to go to the trouble of setting up your own, there are a lot of free resources that are available. TechRadar has them listed here, some of the top ones that are available out there by their own reviews. That's not the Bloomingdale Library's opinion, that's just a public rating system. I have personally used the Google free DNS as well as the Open DNS for different purposes, either here at the library or in my personal work, and I have been happy with both of them. There are others out there that are perfectly fine as well. Those are just ones that I can speak on firsthand. Finally, I'd like to take a look at some troubleshooting tools with you. These are some basic built-in tools that you would have on your computer that you can use to try to identify what's going wrong when a resource isn't working properly or you're unable to connect to the internet. I'm going to show you 3 different categories of options that we would have here and some simple things that we can do with each. We're going to start out with the command line tools. You would get to this command prompt window by either going through the Start menu and finding the command prompt in the Windows Accessories programs, or you would go to the search bar in the bottom of your taskbar on the bottom left-hand side and type in CMD, and that would pop open the command prompt. You can also use Windows Shell and do these same things if you're more comfortable with that. Now we have two different things that I want to show you here, the ipconfig and the ping. The ipconfig is generally used to get information about your IP address and to do some basic work with it. The ping uses IP addresses to try to identify what might be going on with your internet connection. Showing here on the right, I have a window after having run the basic ipconfig command on a test machine. And it shows here that we have the network name on the top, a IPv6 address that's provided there, an IPv4 address. You can see how that fits into the class A that I showed you before, where it's 10 dot, and then it has a range there, a subnet mask, and the default gateway. So this would be the gateway device that is connecting to the internet, and this would be within the range that's provided by that subnet mask. If you wanted more information, instead of typing in the command ipconfig, as you see I typed in there, you could type in ipconfig /all. So you put a space between it, and then you type in the command showing here. That would give you much more detailed information about your IP address. If you are using DHCP and you are connected to a wireless network, but you're unable to connect to the internet, you might have an issue with a conflict. We talked about that a little bit earlier. You can't have any duplicate IP addresses with DHCP or with anything, but they're more likely to come up when they're dynamically assigned. And so if that's the potential problem, the way you would solve that is by releasing the DHCP. Now, if you're not comfortable with doing this, you could also just turn off and turn on the computer, and that would, again, request a lease very often, and that sometimes would get you a new IP address. But a way that will definitely work is you can go through and type in ipconfig /release, and that will release your DHCP information. And then if you run the ipconfig /renew, you see I have these two different commands separated by a little pipe there, but there are two different things that you would do. The renew would request, again, DHCP information, and typically it would give you a different address. So if you happen to get unlucky and you landed on a fixed resource that they had available because they didn't set up the IP range properly with the DHCP server, then that might allow you to connect to something else. Last two things that I have there are kind of informational tools that you might be curious to read. These are ways that you can use the ipconfig command to get information about domain name service connections that your computer has made recently. So the display DNS command typed in after ipconfig would show you stored connections that you have within your computer. These would be places that you could get to by name quickly. The flush DNS is a way to clean that out. You won't use this that often, but every now and then you might be dealing with somebody with tech support, and if you're having trouble pulling up an online resource, they might think that you have incorrect information stored in your DNS records, and they might have you flush that out after first searching to see if it was there. And so that's something that comes up now and then. It's not nearly as common as just wanting to look up the ipconfig information that you have. One other situation that you might have, say you're connected to a wireless network and your device is saying that the connection is just fine. You have a lot of bars, seems like a high quality connection, but you're unable to get on the internet. If you check ipconfig, you might see that there's no IP address assigned. It might just have blank space after the IP address. Sometimes it happens that the wireless network has run out of IP addresses. If the DHCP lease is set for too long a time, or the wireless network is a very high traffic area, sometimes all of the possible addresses can be assigned to other people, and you can have a problem where you don't have one available to you. So you will connect just fine to the wireless access point, but your device will not be assigned an address, and so you won't be able to connect to the internet. Sometimes just restarting and connecting again will solve that problem. An address will have freed up during that period of time. Other times that's something you need to let the network administrator know is a problem with their setup so that they can hopefully do something to open up more possible addresses for you. So those are some things that you would do working with the ipconfig. Now the ping is something that you would use for checking your connection. First basic thing that I have you doing here is checking your internet connection just to make sure that you're able to connect to the internet at all. And to do that, you can ping any resource that is outside of your local private network. So this is going out to the public, to the wide world of the internet, and connecting to something that is out there. I usually use Google because Google is pretty reliably always on, and 8.8.8.8 is easy to remember, and that is Google's IP address. So if you ping 8.8.8.8, if you are connected to the internet, you should see what I show over here, a reply in a relatively short period of time. If you see that you are unable to connect, if it says that your request timed out, then that indicates that you do not have a working internet connection. So you know that there's a problem there. If that's the case, the next thing that you would want to do is you'd want to check to see, am I even able to connect to my gateway? Am I able to connect to my cable modem or wireless access point, or however it is I am getting from my device out to the internet? And to do that, you would ping and then space and then type in the gateway address. If you don't know that, you can get that from ipconfig. So in this case, it would be the 10.1.14.1. You should get a reply from that if your local network connection is working and the gateway is up and running. Sometimes it could be as simple as the access point was turned off or unplugged, and if you can't connect to that, you could say, okay, well, I know there's a problem between my computer and the access point. It's not necessarily the internet out there that's the problem. It's somewhere within our network that we're unable to connect to here. So that can give you some valuable information. Finally, if your internet connection is working fine and you're connecting just fine to the gateway, but you are unable to connect to a resource, maybe it's a server that you're trying to get information off of, you're trying to log on to your computer and it's unable to connect to the server where it pulls your user information from, or you're trying to send something to a printer but the printer is not responding, you can try to ping that specific device. Now, to do that, you would need to know the IP address of the device you're trying to connect to, whether it's a server or a printer or a scanner or whatever it may be. You'd have to have the IP address for it. But if you have that, you can ping that specific address, and you should get a bounce back, again, relatively quickly. If it is timing out, then you know that there is a problem between your computer and that device. Usually it indicates an issue with that device if your computer is working fine otherwise. So those are ways that you can use the command line to check information on your network and get some quick responses. Very often when internet-enabled things fail, we can fly into a bit of a panic and not know what to do. These are some basic tests that you can do to see what might be going on and to point you in the right direction for what the problem could be. Now, another troubleshooting tool that I find helpful every now and then is just checking really fast that my public IP address is still working as it should. To do that, I go to either whatismyip.com or one of the many speed test sites that are out there. This is one that I use. I am not particularly endorsing either of these companies. There are a lot of places that do the same thing. These are just ones that I use as a quick resource to be able to check. What they will do is they will tell you what the public-facing IP address of the device that you're on is. So if I go to ipconfig, that will tell me what my IP address within my local network is. But if I go to whatismyip.com, it will tell me what my public IP address is, and so that is the public IP address that my internet service provider is giving to my gateway. So that lets me know that I am connecting just fine to the internet, and it's seeing that. It will usually give you internet connection information like you're connected through Comcast to the Chicagoland area, or you're connected through AT&T, or whatever the relevant information is, you will see that here as well. If that's not coming up, that could indicate simply that you're not able to connect to the internet, or that there is a problem with your IP address. If you're in a situation where you have a fixed public IP address, maybe you use a VPN, maybe you pay for a fixed public IP address because you're a resource that people connect to online for whatever reason, then you can check to make sure that's working with this as well. Finally, I talked a little bit about the control panel. I want to go back to some of the things that we talked about before. We're looking here at, again, you would go to the control panel, the network and sharing center, and the connections, and that would bring up this screen that we looked at before once you've gone through and you've selected the TCP/IP version 4 properties. A couple things that we talked about before here. This is where you would have verified that there was activity and that the data numbers were climbing. You would have verified that the connection was enabled. And finally, you would check the IPv4 settings to make sure that the device is either using DHCP, as we have selected here, or that it has the settings correct. Before I showed you if you actually typed in the IP address, how that would look. This is how it looks when you have DHCP working to automatically obtain the addresses. And this is, again, what I would recommend for most users. So it looks like something is wrong. It shows blank values in all of these, but that's just because it's automatically obtaining them, and that's just fine. Again, the problems that you're likely to see related to DHCP are you might have conflicts if your IP address is the same as something that is fixed on the network. And so that's something to watch out for. If you are seeing that coming up, what you can do is you can try changing your IP address to something that's just off. You change the last number to one more or one less, and you can try pinging the IP address that you were before. If you get a response, that indicates that something else on the network is using that IP address. That's a quick way to test that. Other situations that you might run into, if you're not having enough addresses available for DHCP, you might want to shorten the lease time. One situation that you have a lot in places where there's a lot of short foot traffic, say you have a coffee shop or a restaurant where people come and go a lot, even if they don't use your network, when people walk in, if their phones are set to automatically connect to Wi-Fi, then they will grab an address. And so they might be in there for 5 minutes just quickly picking something up and leaving. But if you have your lease set to 24 hours, then that phone that was only there for 5 minutes is using one of your addresses for 24 hours. So if you work somewhere that has a lot of in and out traffic and you want to make sure that people aren't grabbing the addresses for too long, you might want to shorten up the lease time to 1 or 2 hours so that things are likely to free up over the course of the day. That way you don't have a busy time early in the morning taking all of your addresses for the rest of the day. These are just a few of the things that you can troubleshoot and you can look through once you get more comfortable with the idea of what IP addresses are and how you would use them and how you would check on them. I hope you found this helpful. If you have anything that you would like to suggest more or less of, or any suggestions for this class, please let us know. The address showing here is the library's website and our computer classes page. At the bottom of that is a survey. We're happy to know any classes you'd like to see us offer, any changes you would like us to make. This is a new service that we're providing with these network classes. We're hoping to add more of them as time goes on, so any suggestions are more than welcome. Thank you again for your time and have a great day.